On Wednesday, we did 21 through 30 together as a class, even though I still couldn't tape at that time. Here we go. So we want domain and range. So for our domain, notice that we start right here at -3, and then as it goes across, still covered, still covered, still covered. There's a big jump, but that doesn't matter. It still keeps going and then stops right there at 5. So we start at -3 and we go to +5, including both. For range, it starts down here at -2. As you move across, keeps going, and then stops completely at 2. So it goes from -2 to +2, both with brackets, just like the domain, both solid. 22. Which function has been reflected on an x-axis, translated 3 units to the right, and up 1 unit? So reflected means negative in front. If we translate 3 to the right, that's going to be x minus 3, and 1 unit up would be +1. So this is what we're looking for. 23. If this represents the parent quadratic function, what is the equation? Well, we shifted to the right 2, so in the parentheses, x minus 2, we shifted down 1, minus 1. Notice that it is opening down, and there's a vertical stretch. Notice that you go down 2 to go over 1, so y is equal to -2. (24) What is the equation of the function that has been reflected on the x-axis? Reflected. Translate 2 units to the left, so to the left would be +2, and 3 units up, +3. Again, this would be an f of x. Last one, number 25. The function is reflected along the x. It's shifted down 3 units and left 1 unit. So in the parentheses, if it went left 1 unit, it would be +1. As a result, the graph looks like this. G of x is, and we're going to rewrite this so it's in the right order. The -x² is first, and then the -3 is last. The -3's match, so they got that one right. The negatives match, they got that one right. But look, when it should be squared, it's just x², not x plus 1². So something happened in my original function in this parenthesis to allow, instead of an x plus 1 being shown, just an x. What would have happened in here so that when I added 1, it just went to x? Well, this would have to be -1, because then if you add 1 to that, you just get x. 26. End behavior over here on the left, as x approaches -infinity, f of x is positive. And over here on the right, as x approaches positive infinity, f of x approaches positive infinity. 27. If the parent function is described as a cubic, then which equation describes the graph below? Notice it moved to the right 1 and down 2. It also flipped, it reflected. So g of x is equal to negative. It goes to the right 1, so x minus 1, and it goes down 2, so -2. Oops, sorry. Alright, 28. What is the graph that you're looking for? With the -2 below, it means you're moving to the right 2. So we're going to have a rational just like this. You can also put this in your calculator. Go to your y equals and put in 1 divided by, and put them in parentheses, x minus 2. The graph, and you can see it matches just like we did with the rational expression. Alright, number 29. What is the composition? So you're putting -3x in here and you're squaring it. So -3 times -3 is +9, x times x is x². The negative in front comes there, and then -3. Last one for today, for this day, the square root of -24. Again, you're going to take out that -1, that's the I. The 24 breaks up into 4 times 6. 4 is a perfect square. 6 is just 2 times 3. So it's 6 plus or minus. Again, the root of 4 is, 24 has a 4 in it. So the root of 4 is 2. And the I is the square root of -1. And we left a 6 inside. All over 2. So there's really one more step to do, to take the two coefficients, or constant in the coefficient, and divide by 2. So 6 divided by 2 is 3, and 2 divided by 2 is 1, I square root of 6. And that's day 3.